Question 4, another tricky one. An automobile moves on a horizontal road, on a level horizontal road, with radius 30 meters. They give you the coefficient of friction. They ask you for the maximum speed that this car can go on the road. And you may think that this isn't enough information to work with, but one of the things that you may or may not have realized is that since the centripetal force pulls the vehicle to the center, friction tries to oppose centripetal force. So the centripetal force, let's say there's a circle and the car is over here. Centripetal forces wants to pull it inward and friction opposes. So friction is trying to pull it outwards. So they're just asking you, if the car wants to stay on that circle, what is the fastest it can go? So you'll notice that centripetal force has to be less than friction. If centripetal force is greater than friction, the car is going to pull itself inward. And friction will never be greater than the force it opposes. It can only match that force or be less than it. So the greatest speed it could have would be represented by when the centripetal force is equal to friction, because it cannot be greater than it. So the best you can do is equaling it. And you'll notice that the mass cancels out. The mass is not important. So you'll get velocity squared over radius is equal to the coefficient times gravity, and you can solve for velocity. And then you can just plug numbers in there.